Okay, so we've been talking about chemical reactions and stoichiometry, and now we're going to look at why reactions stop. Okay, so when a chemical reaction is happening, it's going to continue happening until one of the reactants is used up, and generally one is going to be left behind in excess. So the limiting reactant limits the extent of the reaction and thereby determines the amount of product formed. The excess reactants are all the leftover unused reactants. And determining the limiting reactant is important because the amount of product formed depends on this reactant. Okay, so let's take a look at an example. So here we have shown 3 nitrogen molecules and 3 hydrogen molecules. Okay, now if we were to look at how they react to each other in a balanced equation, we would see, if I can get my pen to work here, that nitrogen reacting with hydrogen to make something called ammonia, which is NH3. Okay, if we were to balance that equation, we would need 1 nitrogen molecule for every 3 hydrogen molecules to make 2 ammonia molecules. So if we have 3 of each, nitrogen and hydrogen, we're only going to use one of those nitrogens, and we're going to use all of the hydrogens. So in this particular case, we're going to have nitrogen molecules left over, which makes hydrogen the limiting reactant and nitrogen the excess reactant. Okay. Now we're going to be looking at how to do this mathematically with grams because we're not always going to have pictures of molecules, obviously, to tell which one is limiting and which one isn't. So let's take a look at how to use stoichiometry to make this happen. Okay, so let's figure out how to calculate the product when a reactant is limiting. So here's our balanced equation. Generally, you would have to write this, but we're given it in this particular example. And our problem says if 200 grams of sulfur reacts with 100 grams of chlorine, what mass of disulfur dichloride is produced? So we have to figure out which of these two reactants is the one that's limiting, which one gets used up first. Okay, so to do this, you want to start by picking a reactant. You can use either one first, it doesn't matter. And we're going to use stoichiometry to calculate how much product can be made. Okay, so let's start with sulfur. So we would have, 200.0 grams of sulfur, which is S8 over 1. That's what we're going to start with. And then stoichiometry, we convert it to moles using its molar mass. And the molar mass of S8 is 256.544 grams. So those cancel. Then we use our mole ratio from our balanced equation, and we're trying to figure out how much product we can get. So we're going to use our product as our unknown. So 4 moles of S2Cl2 for every 1 mole of S8. So those moles cancel with those moles. And then we want to calculate the mass of product that we can get. So we need the molar mass of S2Cl2, which is 135.042 from the periodic table. So our moles cancel, we're left with grams. And here we get 421.1 grams of S2Cl2. Okay, so we just figured out that if all of the sulfur is used up, that's how much product we would get. Okay, now let's take a look at the next one. All right, so for step 2, we want to use the other reactant to calculate how much product can be made. Okay, now we always want to make sure we're going to the same product. In this case, there's only one, but in reactions where there's more than one, we want to go to the same product. So we start with our other reactant, which is 100.0 grams of chlorine. Convert it to moles with its molar mass. And the molar mass of chlorine is 70.906 grams per mole. So our grams cancel. Then we need the mole ratio, and it's going to be the same on top, our product on top, 4 moles of S2Cl2 for every 4 moles of Cl2. Those are from our balanced equation, so those cancel. And then our mass of our product, again, 135.042 grams of S2Cl2 over 1 mole. So our moles cancel. Okay, so here we get 190.5 grams of S2Cl2. Okay, so what you want to see is which reactant made the least amount of product. Okay, well, if all the sulfur was used up, it would make 421.1 grams of product. If all the chlorine was used up, it would only make 190.5, which means chlorine is the limiting reactant because it made the least amount of product. Okay, so that also tells us that sulfur is the excess reactant. All right. So one good thing is when you do this calculation, you are already figuring out something called the theoretical yield. And the theoretical yield is basically, if you were to do this reaction, theoretically, if nothing went wrong, that's how much product you would get. And that's what we calculated when we figured out the limiting reactant. So the theoretical yield of our product would be 190.5 grams of S2Cl2. That is the theoretical yield. So not only did we figure out the limiting reactant, we also figured out what's the theoretical yield of our product. Okay, so now that we know what the limiting reactant is and we know which one is in excess, we want to know how much sulfur do we have left over, okay? How much are we actually going to be using and how much are we going to have left in excess? So to do that, we need to figure out how much chlorine or how much sulfur was needed to react completely with the chlorine, and then we can see how much is left over. So for this one, we go back and we start with the one that's limiting, which we said was chlorine. So 100.0 grams of Cl2 over 1. Convert it to moles. 70.906 grams per mole. So our grams cancel. Now, we want to figure out how much sulfur would react with our limiting reactant. So our sulfur is going to go on the top. And our chlorine on the bottom, so it cancels. So those cancel, and then we want grams of sulfur, so we use its molar mass. Moles cancel. Okay, so what we just figured out is 90.45 grams of S8 were used. Okay, that's how much we used. Now, how much did we start with? Well, we know we had 200 grams of sulfur available. We only used 90.42 grams. So how much is left over? Well, we subtract what we actually needed from what we had available, and we can see that 109.6 grams of sulfur will be in excess. So you'll have leftover sulfur that didn't react with the chlorine. Okay, so let's go through one more example here. We want to look at the reaction between solid white phosphorus, which is P4, and oxygen to produce solid tetraphosphorus decoxide. So we're doing stoichiometry. What is the very first thing that we have to do? Write a balanced equation. So let's write our balanced equation first, and then we'll do our calculations. So there's my pen. P4 reacts with oxygen gas to produce tetraphosphorus decoxide. That's a 4, O10. And then to balance it, we have 4 phosphorus, we need 10 O's, so we would put a 5 right there. Okay, so determine the mass of product formed if 25 grams of phosphorus and 50 grams of oxygen are combined. Okay, so we pick one of the reactants to start with, which would be 25.0 grams of P4. Convert it to moles. And the molar mass of P4 is 123.896 grams. We're trying to find how much product we could get. So from our balanced equation, 1 mole of P4O10 for every 1 mole of P4. Our grams canceled back here. And then the mass of our product, 283.886 grams per mole. So our moles cancel. Okay, so if the phosphorus is limiting, we would make 57.3 grams of our product. Okay, now we need to check the other reactant. So 50.0 grams of oxygen gas. Convert it to moles. The molar mass of oxygen gas is 31.998 grams. Where did my pen go? Grams per mole. We want to figure out product on the top, oxygen on the bottom. This time it's 5 moles of O2, so those cancel. Again, molar mass of product. Per mole, so the moles cancel. Okay, so now if oxygen is the limiting reactant, we would make 88.7 grams of P4O10. Okay, so which reactant makes the least amount of product? The phosphorus does, right? So we're not going to make this. That's what we're going to make. So question A says, determine the mass of product formed. Well, that's what we just figured out. So that's the answer to question A. That's how much product would be formed. That's our theoretical yield, okay? And then question B says, how much of the excess reactant remains after the reaction stops? Well, what's our excess reactant? It's oxygen. So we need to figure out how much of our 50 grams of oxygen are we actually going to use. So we go back to our limiting reactant, 25.0 grams of phosphorus, convert it to moles. This time we want to figure out how much oxygen are we going to use. So we want our moles of oxygen from our balanced equation. So the moles of phosphorus cancel. Then we want the molar mass of oxygen. Moles cancel. So this tells us that we would use 32.3 grams of oxygen. Okay, now the question says, how much of the excess reactant remains after the reaction stops? Well, we started with 50 grams, we used 32.3, so 50 minus 32.3 tells us that we would have an excess of 17.7 grams of oxygen. So that's the answer to question B.